So hi all. So in this video we can discuss how to create a SLR parsing table and how this parsing LR parsing is done. Okay. So here in this the contents here we are going to discuss about the LR parser. What is a LR parser? Okay. Then how we can construct a SLR parsing tables. Okay. So about LR parsing. So LR parsing is nothing. It is also a bottom-up parsing. So here it is the most efficient method of bottom-up parsing, and it can be used to parse a large class of context-free grammar. Okay, so here this LR parser is used to parse a context-free grammar. And why the name LR parser? Because the scanning is done in the left to right direction. So the input symbols are scanned from the left to right. And the R means it is constructing the rightmost derivation in reverse. Okay. And there is a K value. K is an integer value. That means that number of input symbols of look ahead that are used to make some parsing decisions. That is, it will look upon the next symbol, the number of symbols that is looking at the next symbol. Okay, so once if suppose there is an input symbol scanning A, okay, the next it will, or the some parser will look on to the next symbol also. Okay, so that the very next symbol that has never scanned. Okay, so that type of parsing is called a LR parsing. So here if the value of K is equal to 0 means that that is not here. These are the types of LR parser. That is LR 0 is there. So here K value is equal to 0. That means this type of parser never look to the next symbol. Okay, so there is no look ahead. Here in this type, it will look to a one symbol. Okay, look ahead is one. Okay, here also this LALR means look ahead, look LR parser. Okay, next is a CLR parser. Okay, these are the different types of LR parser. Everything is a bottom up parsing. Okay, so this is a model of a LR parser. So we have discussed in the shift reduce parser. The same model is given here. So the working is same as of the shift reduce parser. The operations are, everything is same. So here there is a LR driving program or an algorithm will be there, and we will be having a input buffer will be there, and we will have a stack will be there. Okay, stack will also be there. Okay, then the difference in there is a parsing table is there. Okay, so here we have a parsing table, and the difference in the parser, we have the four types of parser, right? LR0, SLR parser, CLR parser, everything is there. The only difference is in the construction of this parse table. Okay, so here but different methods are used to construct the parse tables for each type of parsers. Okay, so here and here in this parse table, there are two different functions are there. So first one is action, and second one is a go to. Okay, so these are the two different functions that are used to construct a parse table. Okay, and in action we have the all the operations, shift reduce operations, that is shift, reduce, accept, and error. So here in the action function we have the four operations that is done in the shift reduce parser. Okay, so we can anyway we have to study in detail in the coming slides. We have in detail we have to see about everything about this. So again LR algorithm left, the LR parser algorithm. So here this particular algorithm, driver algorithm, requires a stack input buffer. You will get an output, and anyway there is a parsing table will also be present here. So here that is LR parsing in all type of LR parsers. Okay, there are different types of parsers are there. In every type of LR parsers, the input, the output, as well as the stack remains the same. Okay, so the only difference is in the construction of the parsing table. So we need to know the how to construct a parse table for different types of parsers, LR parsers. Okay. And about the input buffers here, input buffer, we can use a, dollar symbol to indicate the means end of the input buffer, similar to the parsers. And there is a stack is also there, and we can have a end marker to represent the stack, bottom of the stack. Okay, and we have a two-dimensional array for parsing table, and it has two different parts, that is a action part as well as a go-to part. Okay, so again we have to see about LR1 parsing. We have seen that whatever the parser is, the only difference is in the construction of the table, parsing table. All other steps remains the same. Okay. So here, if you are given, so these are the various steps. If you are given an input string, you have to find out, or you have to write the context-free grammar for the particular string. Okay. So first you have to, if it is given, then it's okay. If the grammar is given to you, then it is okay. Okay. So first you have to write the context-free grammar. Okay. Then we have to check whether the grammar is ambiguous grammar or not. Okay, so next we have to check for the ambiguity of the grammar. So the third point is that we have to add a new production to this particular grammar, and now your grammar will become a G dash. Okay, so that production is called a augment production. So we need to study what is a augment production, that we can see in later slides. Okay. Next step, you have to create a canonical collection of LR0 items. But this is also thing, items is also another thing that we have to study. Okay, so here LR0 means it is a LR0 parser means it is the least powerful, and whereas the CLR parser, that is the most powerful parsers in this type of LR parsers. Okay. And in order to construct this LR0 as well as a simple SLR parser table, we have to find out this LR0 items. Okay. And for LALR and CLR, we need to find LR1 item. Okay. So anyway, we have to discuss everything in detail. Okay, we can see in later slides. Okay, so after creating the LR0 items, next we have to draw data flow diagram. Okay, so with the help of this DFA, we have to represent the items. Next, after constructing the DFA, then we have to construct a parsing table, that is a LR1 parsing table. Okay. So these are the different steps that is involved in a LR parsing. Okay. So again, so next we have this we have already discussed. Okay, there are four different cases are there. That is a shift action. Then next is a reduce action. Again, we can have a symbol M. Whether it is moved to the stack or not. Again, we need to put. Anyway, these cases we can discuss with an example. Then you will understand more clear. Okay, you will be more clear. So next is what are the different types of parsers? That is, first one is a LR0 parser. That is simply a parser. Okay, that is the least powerful thing. And next, the first thing is we have a simple LR parser. So LR0 is different from LR1, SLR1. Okay, so in our syllabus, we have the first syllabus. We have to construct. The first thing is to construct the symbol LR parser. That is SLR parsing table is a first topic given here. Okay, so that is why I have given a symbol as LR parser. Okay, so here this is a parser which works on the smallest class of context-free grammar. Okay, here also we have a small number of states, and therefore we have a very small table is constructed. It is very simple and it is a fast construction. Okay, table. Okay. So next type is a LR1. Here this one represent, that is we look ahead is 1. Okay. So here also it works on the complete set of LR1 grammar, and it will generate a larger table and it will have a larger number of states. Okay. the construction is a bit slower when compared to SLR. Okay. So again, the LALR means look ahead LR parser. So here it works on the intermediate size of the grammar, and the number of states will be a same as that of the SLR1 parsers. Okay. So coming into the detail, that is first we can see what is a SLR parsing. Okay. So SLR means it refers simple. S is simple, then LR is LR parsing. Okay, it is same as of the LR0 parser. The only difference is that in the construction of the parse table. Okay, so here in SLR1, we have to use a canonical collection of LR0. For LR0 parsing also the same can be used. That is a canonical collection of LR0 can be used for SLR0 parsing also. Okay. So anyway, we need to discuss about SLR parsing table only. Okay. So here in SLR parsing, we need to place the reduce move function only in the follow of the SLR left hand side. That is okay. So here, so when we see the example, you will be clear about this sentence. That is, we need to find out the follow of the non-terminals. Okay, and based upon the symbols that is inside the follow, for that values will be given the values in the inside the table. Okay, in SLR. So, okay. So these are the same steps. So here the difference is that in the same steps in SLR parsing here, the only difference is that here the construction of the SLR parse table has to be constructed. Okay, this is the only difference. So we can see one by one. So here we are assuming that we are given a context-free grammar without any ambiguity. Okay, so the first two processes done. Okay, next step is to we have to add a production, right? For that production is called as a augment production. Okay, so now we have to see what is a augment production. Okay, so this is a augment production. Okay, so here our grammar will be now grammar will be G dash. Okay, so we need to add one more production for the into the given grammar G. Okay, so if we are considering this as a grammar, that is S gives AA and A gives AA or B. Okay, then the new production that is added to the grammar G is that is S dash gives S. Okay, so here this is a new production that is, so this is the new production that is added to a grammar G. So when this production is added, our G becomes G dash. So here this is a augment grammar. Okay, so that is S gives S. S dash gives S. Okay, so here what is the use of this augment grammar? So here it will help the parser to identify when to stop the parsing and announce the acceptance of the input. So here in order to identify when we have to stop our parsing, okay, and whether the given input string is accepted or not by a parser. So in order to know that, we can have a new production is added, that is a augment this production. Therefore, a grammar will be termed as a augment grammar. Okay. So next is after adding that augment grammar, we have the second thing. We have to create a canonical collections of LR0 items, right? So LR0 items is used to construct the LR0 parsing table as well as SLR parsing table. Okay. So since we are constructing SLR parsing table, from here we can have a LR0 item. Okay. So what is this item? LR0 item. Okay. So that means that we are adding a dot operator. Okay. So we are adding a dot operator to some positions on the right hand side of every productions in a grammar G. Okay. So if a dot symbol is added, okay, if a dot symbol is added to every production in the grammar G prime, then we can say that it is a LR0 item. So we can consider example. So here we have given a grammar. Okay, your the same grammar, that is S gives SAA and A gives A or B. Okay, so again we need to add our augment production, and we need to insert the symbol dot symbol, right? So initially we are inserting this particular symbol at the first position of every production in a grammar G. Okay, so here we are inserting at the first position. Okay, so here this is a LR0 item, that is S prime gives dot S, again S gives dot A gives dot A, then A gives dot B. Okay, so next, here LR0 item is useful to indicate how much of the input has been scanned up to a given input in the process of parsing. That is, if a symbol S is scanned, okay, by a parser, then this dot symbol will be moved forward. Okay, suppose we have scanned a capital A, then this dot symbol will move forward. And if again another A is also scanned, it will move at the end. Okay, so that is, so here, suppose my symbol is, if this is the case, if this is the case, then this means that I have scanned the input capital A. Again, I need to scan one more A is there. Okay, so if this is the case, this A dot, that means I have scanned everything in the production. Okay, if one symbol is scanned, then this dot operator will be moved forward. Okay, so we will know that what means how many symbols have scanned from the input. Okay, so again, in the LR0, we place the reduced node in the entire node. So here, this is the case of the LR0, 0, okay, parsers. Okay, so I hope it is clear. And we look on the more example, it will be clear, more clear to you. So next term is a closure. Okay, what is a closure? So about the closure, so first we need to this also will come under the canonical collection of LR0 items. Okay, so here first we have to find out the closure of our start production, initial production, that is the augment production. Okay, so here this is the augment production. In order to when we define the word closure means, so here we have a dot operator, right? So if the next symbol of the dot operator is a non-terminal, so here in this case, the next symbol of that particular production is a non-terminal, then we have to take all the productions from that particular non-terminal. So if we are considering an example, so this is the grammar given, okay, the same grammar, and I have the dot operator at the first place of every production. Okay, so we need to add all the productions starting with S to the state I0. So I am creating a state I0. Okay, and since our non after dot, so we are finding out the closure of this production. Okay, so after the dot we have a capital S here. So here I need to add all the productions that starts with S, that is, this is the production, right? So here I can have, initially I have this production at the initial state. Again, I need to add this production also, because this dot operator is followed by a capital S. Okay, so now my state I0, that is the first state. Okay, So the state I0 will be having two production, that is S prime gives dot S, and I have added the new production because this dot symbol is followed by a capital S. So I need to take that production also, that is S gives dot AA. Okay. So when we look to this production also, this dot operator is again followed by a non-terminal capital A, right? So here we have to add that productions, the productions that start with this non-terminal A. So here there are two productions are there. That is A gives this thing and A gives this thing. So here we need to add the productions, production number 3 as well as 4 to I0. Okay, so here that is what here. But here there is also another symbol capital. It starts with capital A. So I need to add these two productions. That is A gives dot AA and A gives dot B. So this is a state I0. Okay. So this is what we are doing in a finding out the closure of S prime gives dot S. Okay. Okay. So next, we need to, next is a, next operation is a go-to operation. Okay. So go-to operation means if you have, we have a state I0, right? So once this symbol S is scanned, so next I need to go to a different state. So that is what this operation does. That is go to another state. So go to I0S. I have read a symbol capital S in the state I0. So here I have a state I0 is there. Okay, this is I0. At my current state I0, I got a symbol. My parser is scanning the symbol S, capital S. Okay, so here I'm saying that my symbol S is red. Okay, so the state transition occurs, right? So it will move to a different state, that is it will go to a state I1. Okay, and it seems that we have read a symbol S, right? So this dot operator will move to the this that is it will move forward. This production, this S prime gives S dot. So this will be the production will come as like this thing. Okay, is that clear? Okay. Next, we need to see that if a dot operator comes at the rightmost end, that means that that state is a closed state. Okay, that is it has visited all the symbols in that production RHS of the production. So we can have that state as a closed state or a final state. Okay, so here the productions here this production is reduced to close the state. Okay, we have read a symbol and therefore the state has transition. Stage transition occurs from I0 to I1 after the symbol S is read. Okay, so here we have this go to operation applied to the state I0 when I got a symbol S. Okay, now my current production or the current production will come as S gives S prime gives S dot, which is the state I1. Okay. So here the when a dot symbol appears at the end of the production, then we can close that particular state. Okay. So here we need not to move forward after the closed state. Okay, it is same as a final state or acceptance state. Okay. So this is about the go-to operation. Okay. So next, we can draw the DFA. Okay. So initially we have a state I0, okay, which has all the productions. Okay. After getting a symbol S, okay, this symbol S is read. So this state moves to I1, right? And what is the change in the production? That is here S as read, right? So the dot symbol will be moved forward. So here S prime gives S dot. Okay. So again at I0, I can read the next symbol is capital A. I can read a capital A in this particular state I0. Okay, so when that A is read, so here we have to consider that capital A, the non-terminal A is read in this state I0. Then what happens? Okay, then the state will move to a different state other than I1. It will move to a different state. So here the pointer will move forward. Okay, because it has read a symbol capital A, right? So here I have a production that is S gives capital A dot A. Okay, so this is the only production will come first. Okay, so when we see the closure of this particular production, here after dot, again there is a capital A, right? So I need to apply the closure on this production also. So that is, I need to write all the productions that is starting with A. So I have the production that is A gives dot A capital A and A gives dot B. That is also written in this state I2. Why it is written? So once again I am repeating why this state, this production is written in state I2, because once we have written the state production S gives A dot A, again we need to see at each state change, after each transition of the state we need to apply the closure. Okay, so after this dot, again it will come a dot symbol, sorry, a non-terminal capital A. So here there is again a non-terminal capital A. So we are applying the closure upon this capital A. That means I need to take all the productions that starts with capital A. So here these are the two productions that starts with capital A. So I am writing that two productions too. I am taking these two productions also to the state I2. Okay. Okay. So next, in this state, I can have a symbol, small letter A. Okay, next I am reading if a small letter A, a terminal symbol A is read. Again, the state will change to a different state. That is, my new state is I3. Okay, so here I am writing that particular production that is A gives. So since this small letter A has read, my point, this dot operator will be moved forward, A dot capital A. Okay. Again, the same condition occurs here also. Here also we need to apply the closure upon this capital A. So here I need to take all the productions that starts with capital A. That is the production A dot A and A gives dot B. That's why I have taken this production also. Okay, to the state I3. Okay. So next symbol that can be read at the state I0 is B, right? Small letter B, that is a terminal symbol B. Okay. So I am reading a symbol B. Okay, after this symbol B is read at the state I0, then the dot operator will come at the end of the production, right? So that means that it has come to the end. Okay, that is, it will reach a closing state. That is, A gives B dot. This means that it is a closed state. So this green color states, that is I1 and I4 represents a closing state. Okay. Okay. So next, that is wherever we apply a goto. So here, wherever we have applied a goto function, we need to apply the closure also. Here we had applied a goto here, right? So we need to check for closure also for every goto functions. Okay, that is what it is specified here. Okay. Here we apply the closure here as well as here. Okay. So next is here, these are the I2 and I3. Again we can expand, right? So this point is reached here. So again at this state, at the state I2, when a symbol capital A is scanned, okay, at the state I2 a capital A is scanned, then again this dot operator can move forward, right? So a new state can occur. Okay, so here I have a new state, that is S gives A dot. Okay, so here dot has come at the rightmost end of this production, then we can say this, the state I5 is a closed state. Okay. So again, I can have another input, right? So here there are two more productions are there in the state I2. So I can have a letter or a B letter. So first we can consider the terminal A. So if we got a terminal A, then it need not to move to a new state. So if we got a non terminal A, then this it can move to the state I3, because the I3 is also having this A. When we read A, after reading that process is done in the state I3. Okay, again, need not to repeat the same steps, right? So here, after getting A, it can move to the state I3. So here, this A is read here, this production. And after reading A, the same thing is done here. Okay, closure is applied here. Okay, the same in this case also. Here, that is, here we have read a symbol B, right? Okay, so when B is read, then what you have to do? That is, the dot symbol will move at the rightmost end. That is this state, right? So again, I2 can move to I4 when a terminal symbol B is read. Okay. Okay. I hope it is clear. So next, again, so here I have read all the symbols. That is, capital A is read, small letter A is read, small letter B is read. Okay, that state is completed. Again, about the state I3, what we have to do in I3. So here, after this A, here the dot symbol is coming. After the dot symbol, a capital A is coming, right? What you have to do when non-terminal symbol A comes at I3. Okay, so here we have a symbol A is there. So that means that dot will come to the state, like at the rightmost end. So that means that we'll have a state I6. So A gives A, capital A dot. Okay, so here this is the state. Okay, so again, so here when we consider this small letter A, so when small letter A comes, what you have to do? So the production is same as this production, right? Again, it will go to the state I3. So we can loop in and that case itself. That is, when we get a small terminal symbol A, then the state is going to the same state I3. Okay. And about B, that B, if we get a letter B, then it can go to I4. Okay. Okay, so when a letter B is get, then we have a transition, state is transition to the state I4. Okay, is that clear? But this is a final DFA, data flow for the close after constructing all the canonical collections for the LR0 items. Okay. So by using this DFA, we need to construct our parsing table. Okay. So here we have done the created a DFA, and it has 7 states, that is from I0 to I7. Okay. These are the different steps you need to construct a DFA. Okay, so whenever we go to when we apply a go-to function, we need to check for closure also. Okay, that is a main point that has to be that should be careful. Okay, so next we can see how we can construct a table, that is a SLR parsing table with the help of the DFA that we have created. So next we can see the SLR parsing table construction. Okay, so here these are the rules that we need to see. That is, if a state ij is going to the some other state, I is going to the some other state in ij on a terminal. Okay, if we have a terminal symbol read, then it will correspond to a shift to move in the action part. So here this is the case. If your state is in I and you are moving to a new state ij, and you have a terminal symbol, small letter terminal symbol A, then what you have to do in the table. So here the table parsing table will be having a action part as well as a go to part, and the row column represents all the symbols. Okay, the terminals as well as the non-terminal symbols will be represented inside the go to part, and the terminal symbols and the dollar symbol will be inside the action part. Okay, and the row represent the states. Okay, all the states will be represented here. Okay, so here I have a at the state II, right? Here I am having a state II, and I have a input symbol, terminal A is red. So at the place A, now I have moved to the new status IJ. Okay, so I can have a shift operation. So I'm representing it as S for shift, and a number. Okay, the state number J. So here I can write the entry as SJ. Okay, so this is what we are doing in a when a terminal symbol is red. Okay, so next case is, so here when a terminal symbol is red, we have to do the entry in the action part. Okay, so next we have a non-terminal symbol. Okay, here we have a non-terminal symbol from I to IJ. A capital A is red. So again we have a entry at the go-to part. Here we have the entry at the go-to part. So at the non-terminal symbol A, we just write the number. So here we have S and the state number, because to show it as a shift operation. So here just we need to represent as a number, that is the state number is represented here. That is J. Okay. That is how we can do the entry in the parsing table. SLR parsing table. Okay. So next is another thing, that is if we have reached a, if the state is a final state. Okay. So here in this case, we have, that is A gives, here this is a production, and here the dot symbol is appearing at the rightmost end, right? That means that we have this final state or the closed state here. Okay, so then we have to mark the production, that is we have to mark under, we have to find out the follow symbols, follow of the non-terminal A. Okay, so here this is a non-terminal A gives something, right? So here we have to find out the follow of A, and the symbol is A, small letter A, the terminal symbol A. So inside the table, we have to write, or we have to put an entry at the place I, and small letter A. And we have to write it as reduce, and the number is 2. The 2 means represents a state number. Okay, so here it is, whenever we have a final state, you have to put an action, reduce action. Okay, so if our symbol is a terminal symbol, then you have a shift operation. Okay, so here in this SLR parser, it is similar to the LR parser, except in this particular reduced entry. So here in LR parser, if you have a entry, reduced entry, you have to write it in all the in every column of this particular rows. Okay, in the action table, action side, not in go-to. In action, you have, if R2 is here, you have to write in R2 in B side, and here in this column also we have to specify R2. But in SLR parser, we have this, and the entry is restricted only to the symbols which comes under the follow of that particular non-terminal. So that is the only difference between the table construction of SLR and LR parser. Okay. So here we can see an example. Okay. When we see an example, it will be more clear to you. Okay. So here the row represents the state, as well as the column represents the symbols. right? So here inside the column you have two functions, that is action and go to. So in action we have the not action, we are specifying the terminal symbols, this is small letters, and finally we have that dollar symbols also, right? Okay, and in non-terminal we have the we can specify it in the go to function. Okay, so next we have to this is the this is our DFA. Okay, okay. Now we have a table, that is a SLR parsing table. This is the initial state of our table. That is, we have a state which is represented as the call. Each row will be representing the state. And for each column, we have the terminals and non-terminals. That is, we have two parts, right? That is action part and the go-to part. So inside the action part, we have the terminals. That is, here in this example, we have the terminal symbols A, B, and dollar symbol. And the non-terminals are capital S and capital A. So next, we can start constructing our SLR parse table. So we have our DFA. Okay. So this is a table. Now it is empty, and we need to enter all the values. So first we can start with the initial state, that is 0, right? I0. So here this is I0, I1. So this number represents the state numbers. Okay. So here first we can take I0, the initial state. Okay. So at I0, so and when a non-terminal symbol A has taken, okay, at the state I0, when A comes, what is the action that has to be done? Okay, so here when at the state I0, when a symbol A comes, okay, so here the state is changed from I0 to I3, right? So we can mark an entry S3, that is a shift 3. So 3 represents this state number. Okay. Shift 3 at this position. Okay. So now we have our first entry in our table. Okay. Okay. So initially consider the states. Okay. First we can consider the initial state and our terminal symbols. So we have to find out inside our DFA, that is when I0 at the current state I0, when A comes, it will be the state is moved from I0 to I3. So here we have to write S3. So S represents shift and 3 is the state number. Okay. So next we can do the second operation, that is now we have our inside the table we have this entry S3. Again for the state S0, state I0, then we have a non-terminal, sorry, terminal next. Also we can consider the terminal symbol B. Okay, so when B comes, what will happen at state I0? When B comes, it will move to I4. So we have our entry S4. So S represents shift and 4 is the number, state number of this particular state. Okay, so there is no entry for the dollar symbol, right? For the state I0, there is no symbol is derived for dollar symbol. So you have to mark for that. Okay. So next we have the non-terminal symbols S and A. So next we can do it in the go-to part. We can move to go-to part at the state I0. When capital S as read, then it will move to I1, right? So at the state I0, at the state I0, when the symbol S is read, then the state will move to I1. Okay, so here inside the go-to part, just write the number of the state. So no need to write the shift operation here. Okay, so inside the go to part, just specify the number, state number. That is here it is 1, right? It is I1. So just write 1 here at this position. Okay. So similarly, in when at the state I0 when A is read. Okay. So now you have a state I0 and the non-terminal A. So I0 and A, then it is moved to the state I2. So we can have the number 2 at this position. Okay. So here we can write the number 2. Okay. So now our first row is done. And again, moving to the second row, that is, we are considering the state I1. Okay, so this is the state I1. Okay, so now we have a state I1, and which is the terminal. Since I1 is our final state, right? So here, this is the final state. Okay, so here we can mark it. Here we have, if we have read a dollar symbol at the terminals. Okay, at the state 1, if we have read a dollar symbol, that means that we have accepted that string. Okay, so here for the state 1, and that is the state which contains the start symbol. This means that we have scanned all symbols, right? It is S means it is a start symbol of our grammar. So dot is at the end of this prediction. That means we have seen everything in S. So here that is our parsing is done, right? So at this state, if we have encountered the dollar symbol, then that means that we have accepted that string by the SLR parser. So here we have the augmented final production. S prime gives S at state I1. So this is a special production. And this means that we have seen everything of the start symbol S. So we need to write only and accept under the dollar symbol for the state 1. Okay. So here a string will be accepted once we have reached this particular state I1. And it has a if our input symbol is dollar. Okay, then only we will accept a string. So next we can consider the other states, that is I'm considering I2 now. Okay, so I2's inside I2 I have the symbols non-terminals capital A and terminal symbols A and B. Okay, so first I am specifying the non-terminal capital A. So inside the at the state 2, when a non-terminal capital A comes, what is done here? So here when I2 comes and when A comes, it will move to the state I5. So just write the state number 5 here. Okay, so now we have the entry 5 at this particular cell. Okay, now the non-terminals, sorry, terminals, small letter A and small letter B. So again, the small letter A at the state I2, when A comes, then it is moved to I3. So just write shift I3, that is S, and the state number, that is I3 at this location. Okay, so now the entry will be S3. Similarly, for the terminal symbol B at I2, so here I2, when B comes, then it will go to the state I4. So we need to write the entry as S4, that is shift 4. Okay, so here we have the entry shift 4. So this is all for this particular state, and we have done our second row also. Okay, so here when at the state I2 we have only 3 entries, that is capital A and small letter A and B. Okay, so now the third state I3. So what is the third state? So third state is having also having the terminals A and B and the non-terminals capital A. Okay, so first we can go to the terminal small letter A. So here at 3 and if we have a small letter A, a terminal symbol A, then it will again go to the same state I3, right? So here I am writing the shift operation for the same state, that is S3 is specified here, written here in this cell. Okay, okay, that is it is looping in it, it is going to itself, the state is going to itself. Okay, so next if we get a symbol B, so at the state I3 when a B is read, then it will move to I4, right, which is a final state. So we have a S4 here. Okay, this is a shift operation S4. Okay, so S4 is in this cell. Okay, now we can take our non-terminal capital A. So the state I3 and we have the non-terminal capital A. So at the state I3 when capital A is read, then it will go to the state I6. So we need to write only the number 6 in this cell. So here we can write only, need to write the state number 6. Okay. So next to take the next row or next state, that is next state is 4. Okay. So here I have my state 4. Okay. So here this is a different case, that is state is a final state. I4 is a final state, right? So now I need to find something else more. Okay. So I need to find the, first I have to number my productions. Okay. So I have numbered it as S gives A, that is the first production, this is the second production, and this is the third production. Okay. Now again I need to find the follow of follow, first and follow of capital A and S. So in this case I need to find only the follow of A. Okay, so because this particular state I4 is only having the production A gives B dot, right? So here I4 contains the final item which derives A gives B dot. So we need to find the follow of the left hand side, LHS of this production. So therefore follow of A. Okay, so here in this case when we consider this productions, the follow of A is capital small letter A, B and dollar symbol. Okay, so now we need to write the means we need to have the entry for every terminal symbols in this follow of A. So that is, we need to have the entry for small letter A, small letter B and dollar symbol. Okay, so that is, we have the action for I4A is equal to I3, action for I4B is equal to R3, again I4 dollar symbol is equal to R3. So this R represents, we have to do the reduce operation. So till now we were doing a shift operation, right? From 0 to 3 we have the shift operation. When the final state or the closed state comes, now we have the reduce operation, and for the reduce operation we need to find the follow of the non-terminals. Which non-terminal? That is the left hand side of the productions in which means the production in which that particular state contains. Okay, so here in this case the state 4. Okay, and I have my the production A gives B dot is a which production? This is a third production, right? Okay, so here this is the, sorry, so this is the third production, therefore I need to have the number 3. So why this R? This is a reduce operation, so R3. Okay, that is why I have written here R3. So similarly the same condition, that is I have my next terminal symbol, that is B. So here in the state 4 the terminal symbol is B. So again action for I4 and B. So the value will be R3. So that is reduce 3. So how this 3? That is the number from the productions. Okay. So here the productions are numbered, and this is the third production. Okay. I4 is containing the third production. That is why R3. So here corresponds to the production number 3. So we can write it as R3. So similarly, that is again that is R3 specified here. Similarly, we have the follow symbol. Next follow symbol is dollar symbol. Okay, so we need to take the that is 4, and the state is 4, and our symbol is dollar symbol, and we have to write this production. That is, we have taken the production, the third production, so we can specify R3 at this cell. Okay. Okay. So now we have entered the productions. We have all the entry for the state I4. Okay, now we can have the state I5. Okay, what is I5? So here I5 is also final state. Okay, so this is the state, that is S gives AA dot, right? And what is the production number for that particular production? That is 1, right? S gives AA, this is production number 1. So anyway, we will have the entry R1, right? So where should we write it? That is, we have to find the follower of S. So that is the left hand side of this particular production is capital S, right? The non-terminal on the left hand side is capital S. So we need to find the follower of S. So wherever the symbols, so anyway follower of S is dollar symbol. So we need to write R1 only under the symbol dollar symbol. So here, that is why in state 5, and only we are representing, only we can write R1 under the symbol dollar symbol. So here R1 is specified at this particular location. Okay. Okay. So next is I6. I6 is also the final state, and which has a production number 2, right? So the number is R2. Okay, so now we have to write R2, and at which place, that is, I need to find the follower of A, and I need to specify it in A, B, and dollar symbol. Okay, first I am representing it in A. So here it is A, at the location A, I am writing R2 here. Okay, at the next step, I can write the R2 in at the location B, 6B, again R2 is written here. Next, we can have the dollar symbol. So because follower of A contains all the 3 symbols, that is A, B, and dollar symbol, right? So here we have to specify R2 in every columns. In action part, only in action part, okay? Only in action part, that is R2, R2 here, again here also R2. So here, so 6 and dollar symbol, again here it is the R2. So finally we have constructed our SLR parsing table. Okay, so I hope it is clear. So this is a final parsing table. Okay, so suppose when we have come across any other location, that is if 1A comes, that means that it is an error and that particular string is not accepted by this SLR parser. Okay, according to this grammar, that particular string will not be accepted. Okay, so other than the information, means any other place. So here, everything, that will result the error. Okay. So what is the main difference between a LR0 parsing table and a SLR parsing table? So just a small difference is there. So while constructing the table, so here we have construct everything. The shift action is everything same. Okay, is same as that of the SLR parsing table. Only difference it is the reduced part. Okay, so in reduced part we need to write that particular entry in every columns of the action part. That is for every symbols. No need to find the follow of the capital A of capital S. Write that particular value, that is R3 here. If it is R3 in this particular I4, then write in every column in the terminals. Okay, here R1 is written everywhere. Here R2 is also written everywhere. Okay, so here for these states, okay, that is the final states, 4, 5, 6 are the final states. And anyway, we need to find out which production that is used. Okay, so here in this I4, that is in this state, we are using, we have to number the productions, and this production is numbered as 3, and it will be R3. So here, this particular reduced entry R1 should be written under all the terminals in a LR parse table. So this is the main difference between a LR 0 parsing table and SLR parsing table. In SLR parsing table, we need to find the follow of the non-terminal of the left-hand side, and that particular symbols will be having the entries. Okay, under that symbols only we will write the entries. Okay, so anyway, this creation is not in your syllabus, just I have specified. Okay. So now we can consider an example. Okay, with the help of an example, we can pass that particular string, and with the same grammar, and with the help of the sparse string. Okay. Okay. So this is a question that is check whether the string that is A, B, B accepts this grammar. So the same grammar, that is S gives A, and A gives A, and again A gives B is given here. And we have a parse table, SLR parsing table is also given. Okay. So with the help of the parsing algorithm, we need to check whether this particular string will parse, will accept this particular grammar will accept this string or not. Okay. So anyway, this algorithm has three things, right? That is the stack, the input buffer, and an action, right? Action will be having, what are the four actions? That is a shift action, a reduce action, accept action, or the error actions. Okay. So what is the initial state of everything? That is a stack. The stack, initially, the stack will be having the only the state, initial state number, that is 0. Okay, and the input will be having, input buffer will be having the string, that is the string that we need to check, that is ABB, and followed by a dollar symbol. Okay, so and what is the action to be done here? So first we have to check with a stack top. Okay, stack top is a 0, and the first symbol, the scanning is in the left to right direction, right? So first we have to take this particular symbol, that is A. Okay, so 0 and A. So that is, now you consider the table. So under the state 0, when a symbol A comes, what is the action done? So here the entry is S3, right? S3 means shift 3. Okay, so we need to shift, okay, and a 3. So here we have to shift the first symbol to the stack, and also that state number is also shifted to the stack. So what is the state number 3? So here in this case we can shift as well as 3 to the stack. So that is why I have written shift 3. So first shift the symbol in the input buffer, and again shift this value 3. The state numbers also shifted to the stack. Okay. So here this will be the next state, that is 0. We are inputting two symbols at a time. Okay, that is why SLR1. So we are looking one symbol forward for this particular algorithm. Okay, So here A3 is pushed into the stack. Okay. Okay. So next we have a table, and productions is also given. So next, what is the state? So now we have a stack, the input buffer, and your stack top is the state number 3, right? Stack top is 3, and the symbol is first symbol is B. So 3 and the symbol B. So here it is S4. Okay. So S4 means shift B4. That is B is the symbol and 4 is the state number. So here the action is shift B4 to the stack. So now your stack will be 0, 8, 3 and B4. Okay, the input buffer will be having only B and dollar symbol. So now your stack top is 4 and your symbol is B, right? So at the state 4, when B comes, what you have to do? Here comes a reduce action. Okay, so when a reduce action is occurs at the table, then you have to perform the pop operation. Okay, so what is the done? What do we have to done when a reduce operation comes? So here we have to do the reduce operation, and the production is R3. So with the help of the production number 3, that is A gives B, we have to reduce it. So what you have to done in the what are the changes that occurs in the stack and the input buffer? Okay, so input buffer does not have any change, but a stack will have something. Okay, so that is we have to pop some symbols from the stack. So some symbols means if you have one symbol in the RHS of the production, then you have to pop two symbols from the stack. Okay, if you have two symbols in the RHS of the production, then you have to pop four symbols from the stack. That is, you have to pop 2x number of symbols from the stack. Pop 2x symbols from the stack. And what is this x? X represents the number of symbols in the RHS of the reduced production. Okay. Okay, you have to pop everything, that is pop two symbols from the stack, and you need to push something. What is the symbol that has to be pushed? You have to push the left hand side of this production, that is capital A. In this case, capital A has to be pushed into the stack. Okay, so here B and 4 will be popped, and we have to push capital A to the stack. Okay, so table will be, sorry, stack will be in this particular format, right? The 0, A, 3, 3 was there, okay, and A is pushed into the stack. Okay, so again we need to write a number for this capital A, right? For that we have to consider these two symbols, that is 3 and A. So consider the state number 3 and the symbol non-terminal A. So here when the state 3 comes and the non-terminal capital A, what is the value here? It is 6, right? Now push the number 6 onto the stack. Okay. So here, once we have done a reduce operation, after performing all the pushing and popping, your stack will be look like this, and take the last two symbols, that is a first top symbols, top two symbols, and from the table you find out the value inside the go to place. You will find a value and push that value to the stack. Okay, so here I am pushing the value 6 onto the stack. Okay, now I am having the value 6 here. Okay, so now I need to consider, I need to check with 6 and B. What is the operation? 6 and B. Here I have to again do the reduce operation with the help of the production number 2. So here I have to do the reduce operation, that is A gives small a capital A. Okay, so if there is two symbols are there, now I need to pop four symbols from the stack. That is 1, 2, 3, 4. So these four symbols should be popped out from the stack, and I need to push the left hand side production variable in the production, that is capital A, should be pushed into the stack. That is, it will be having 0, and this A will be pushed. That is, capital A will be pushed onto the stack, right? Capital A will be pushed, and we need to have a one value here, right? For that we have this thing on the stack, right? 0 and A. So from the table I need to take the value 0 and A. So here it is 2. So I can push the value 2 into the stack. Okay, is that clear? So here I need to put push A into, then we have to go to 0A, that is 2, and you have to push that particular 2 onto the stack. Okay, so I am pushing A, and the number 2 is also pushed onto the stack. So when I get the number 2 on the stack top, again I need to do the same operation. 2 and input buffer symbol is B, right? The first symbol is B. So 2 and B. What is 2 and B? It is S4, that is shift operation. Okay, so shift S4. So here I need to push this B to stack, and 4, the state number also should be pushed. Okay, so now I am pushing B4 onto the stack. Okay, so my input buffer is only having a dollar symbol. Okay, so again I am checking the same process, that is 4 and dollar symbol. So 4 is a final state. Again I need to do the reduce operation. 4 and dollar symbol is having R3. So I need to take the production R3. A gives B, right? So here I am doing the reduce operation. A gives B. So for that I need to pop these two symbols. Last two, first means top in the രണ്ട് symbols. That is 4 and B has to be popped out. Okay, and I need to push the left hand side symbol, that is A has to be pushed. Okay, so from 0 A to capital A will be there on the stack. Okay, so again I need to have one more symbol, which will be the number, that is 2A, right? 2A. So go to 2A, that is 5. The number 5 should be pushed onto the stack. Okay, so here in this case, I have 2A and the number 5 in the go to function. I can take that number and push that 5 onto the stack. Okay, so again take 5 and dollar symbol, the state number 5 and dollar symbol, again the production number R1. So again do the reduce operation, that is R1, that is S gives AA. So here also there are two symbols are there. So pop 4 symbols, that is 1, 2, 3, 4, 4 pop till up to here, and we can place the left hand side non-terminal on the stack, that is S can be pushed onto the stack. Okay, again I need to push one more thing, that is a number, that is when if 0, if we consider 0s, that number, that is go to 0s, that is the number 1. So number 1 can be pushed onto the stack. Okay, so here I am pushing the number 1 to the stack. Okay, now the stack top is 1 and my input symbol is the only symbol, that is a dollar symbol. So what I have to do, 1 and dollar symbol. Okay, 1 and dollar symbol means the entry is accept. So here now I can take the action, that is accept, that is the string is accepted by a parsing table. Okay, okay, 0 and 1, and here we can have, that is one and dollar symbol. So here this will be the take. Okay, this will be taken, and here we will have a accept action. Okay, I hope it is clear. So here in this here we have discussed how the parsing is done, various steps in SLR parsing. Okay, first step is to create augment grammar, then canonical collections LR0 items, and to construct to draw DFA. Okay, then I from that particular thing I have to create a table, and after creating a table, how this parsing algorithm is working with the help of an example. Okay, okay, thank you.